All right, we are going to start in 3 minutes. I just want to check that you can actually hear me. So you can answer using the group chat if you want to. Okay.
Yes, we can hear you.
Okay, perfect. All right, how many are we? 21. Okay, let's wait a little. So while you are waiting for the other to connect, do you have questions on the exam or remarks that you would like to share with me, with everyone? If so, I believe that you can just activate your audio and talk.
I have a question about the homework.
About the homework. Gaia, is that you?
Yes.
Okay. So just before you ask your question, I would be happy to see your face if you think that this is appropriate given where you are. If not, that's perfectly fine, but that's always better for me to associate a face with someone. Hey, okay. Go ahead.
Okay, so regarding, I know that a lot of things being changed because of what happens, whatever. So
Yes.
are we still following the homework guideline and main tab, or those are being changed?
Okay, I'll show you. I've just changed thing today, and I wanted to share that with you. So your question is perfect. All right.
Because I know there's one that do on the 13th, so that means that it was due earlier than that before, but I guess you put the date back.
Yeah. So
Okay.
basically, I can't assign anything for Monday as it was planned initially. So for the current chapter on costs, chapter 7, I have changed the due date to April 14, which
Okay.
is, I believe, the Tuesday before our next class.
All right.
Okay, and I have also changed all the next due dates. So all the homeworks are now assigned the Tuesdays before the class. Okay.
All right. Okay. No problem.
All right. Any other question?
No, it was just that because I was kind of confused because because like we missed like a lot of days, so I don't know how you want us to keep up with that. But
Yeah, I know.
I,
It's
I get
very
it now.
complicated, and the schedule has been horrible. I know, but
Yeah.
so no, I have extended the due date as much as I could. Okay,
Okay.
for
No problem.
everything.
Thank you.
Someone else? Question about homeworks, exam, anything?
Hello.
Yes.
Hi, this is Zay Ted.
Yeah.
Uh, I have a question about the final.
Yes.
If we get a better grade on the final, can we
Mm-hmm.
have that? Oh, wait, no. Never mind, never mind. Oh, are we still doing the third exam?
Yeah, so, okay. So the grading policy says something like you have 2 midterms. And basically these 2 midterms cover all the chapters. Okay, so one option is that you take these 2 midterms, you see your grade. If you are happy with that grade, then you stop there. If you're not happy with that grade, then you have the option to take a final exam. So the final exam is optional. You have the option to take it if you're not happy with your midterm grade. So the final exam will be cumulative. So it's going to cover all the chapters. Initially, in my grading policy, I believe that I said that the grade you get on the final exam, if you take it, would replace your midterm grade, whatever those grades are. So if you underperform on the final exam, then you would have been better off sticking to the midterm grade. What I'm gonna do is I'm gonna take the best grade. So either you keep your 2 midterm grade as course grade, or if you choose to do the final exam and your grade is better at the final, then I will keep that grade. Okay, it's not going to erase a grade that would be better with the 2 midterm. Okay?
Okay, thank you.
All right, so I know that some of you are worried because you didn't do well on the last exam. So you can still catch up with this option. Okay, you can still take the final cumulative exam and get a better grade. In the overall, I found that looking at the histogram of the grade distribution, I found that the grade were okay, were rather good, I believe. So that's my first time teaching that class, so I have nothing to compare to, but I was kind of surprised that I had to apply a small curve. Okay, in other classes I had applied like huge curve. So I'm happy with that. What else? And also I think that you will get used to online exam and to uploading your file when required. Now that you know that you can only upload one file, so if you want to take a picture of your work, you're better off taking a picture of all your pages at the same time, this kind of thing. So for next time, I believe that you have now the experience of the online exam and you will be able to adjust, okay? All right. I just want to come back to this option to switch to credit, non-credit. So this is really for those of you who end up with a bad grade, a grade that you think will kill your GPA. If your grade in that class is not good enough for you, then you'll have the option to choose to have no credit for that class. And then the grade will not appear on your record. By default, I'm going to enter the grade in CUNY first as usual. And so it's really on your side that you will decide whether you want it for credit or not. I've given you all the information I have on that. Maybe we'll get more information along the way, but for now, that's everything I have. You have question on this? No? All right. Okay, so today I wanna cover the problem set on costs. Yes, the last thing. So I said that for the first midterm, I applied a curve of 4%. Ideally, I mean, in my ideal world, I would prefer not to curve any exam. So my plan for the next exam is to make it a little bit easier so that I don't have to curve. I mean, you're never sure that you will not have to curve, but I'm gonna try to make it a little bit easier than that one. All right. Okay, so now let's, so you will need to go to, in Blackboard, course document, costs, problem set. And here you have the problem set that we are going to work on. So let me share on my iPad. Okay. All right. Oh, yes, again on the video, so I have your name displaying on my computer. Again, I would be happy to see your face if you want to. If you don't want to show the inside of your apartment, which I understand, you can, I believe, put a virtual background, which I'm doing right now. So, I mean, you can do it now or for next time or never. That's really up to you. But I'm always happy to see faces, and that kind of gives some feedback on how clear I am just looking at your face. Okay. All right. So let's move to the problem set. So part of this problem set deals with topic that you already know. So the first two questions here are on economic cost, accounting cost, opportunity cost. That's something we have covered in INCO 1001, so I'm not going to talk much about it. I'm just going to go over these two questions quickly, and then we will move to a more novel question about what is the main topic of this course, which is cost minimization. Okay, so let's look at the first question. Let me take my pencil. Yes, it works. All right. So Jim left his previous job as sales manager and started his own sales consulting business. He previously earned 70K per year, and now he earns 25K per year. Okay, so what is the economic cost of the time he contributes to the new business? All right, so when we talk about the economic costs, it usually includes two things. So usually the economic costs, when you calculate the economic profit, you include the economic cost, which include both explicit and implicit costs. Okay, so what are explicit costs? Can someone remind me what are explicit costs? Someone?
Wait, can you repeat the question again, please?
What are explicit costs?
Wait, isn't it?
Rent, supplies, payroll.
Yeah, exactly. So basically, any kind of cost that would require a cash transfer. Okay, that's explicit cost. And these explicit costs are also called accounting costs. Okay, that's the one you take into account when you calculate the accounting profit. So here, the question is about economic costs. So in that question, we don't have any explicit costs. Okay, what we will have is implicit costs. So what is the implicit cost here of running this new business?
His lost salary?
Exactly. So initially he was earning 70K per year, and now he's not doing this job anymore. So he pays himself 20K per year. Okay, so basically the difference between what he earns before and what he earns now is the opportunity cost of the new business. Okay. Okay. So the opportunity cost is an implicit cost, that's the same thing. So the question, what is the economic cost of the time he contributes to his new business? Well, that's the difference between 70 and 25. So that's 45. All right. Question on this? Okay. Let me just check how many we are. Okay. All right. So let's move to the next question. A firm's economic profits are given by. Okay, so that's again something you should know, but I'm going to say it again. So what is the economic profit? So the economic profit, usually we call it a pie, is the difference between total revenue, we call it TR, total revenue, minus economic cost. Okay. So usually total revenue is simply the quantity of a good sold, Q, times the price, the market price for that good. Okay. The economic costs, as I've just said, include both explicit plus implicit cost. All right. Okay, so what is the economic profit? Well, that's total revenue, TR, minus economic costs. So the answer here is C. Okay. Okay. Let's move to question 3. So suppose the price of labor is 10 and the price of capital is 20. What is the equation of the Isocosts line corresponding to a total cost of 100? Okay. So first, what is the Isocost line? So let's draw a graph. You put a labor on the x-axis and capital on the y-axis. Okay. So the Isocost is the set of combination between labor and capital that generate the same level of costs. Okay. So that's the Isocost.
Sorry, could you repeat the Isocost again?
The Isocost is the set of labor and capital, so that the combination of labor and capital that generates the same level of cost. So for instance, you can say this Isocost corresponds to a total cost of 100. Okay, as in the scenario. All right. So how do we get the equation of the Isocost? Okay. So when you hire a number of workers equals to L, and you pay a wage of W, then it costs you WL. Okay. And then you can use a certain amount of capital of machine. Okay. And let's say that the rental rate for this machine is V. Okay. So here you're gonna spend WL for, that's the labor cost, and VK, that's the capital cost. Okay. And the sum of WL and VK is the total cost.
So the answer is B?
So exactly. So here the price of labor is 10. So you have 10L plus the price of capital is 20K. And this is equal to a total cost of 100. Okay. So that's the equation of the Isocost line. You have question on this? All right. So before we move to the next question, maybe I'm gonna add something here. So this is the equation of the Isocost line, but usually we want to express the variable on the y-axis as a function on the variable of the x-axis. Okay, so if you really want to write down the equation of the Isocost, then you want to express k as a function of the rest. Okay, so let's say that your total cost is fixed to a certain amount. Then you will have VK equals TC minus WL. Okay, and you have K equals TC over V minus W over VL. Okay, so that's the proper way of specifying the equation of the Isocosts. Okay, so from this expression, you can see that the slope of the Isocosts is going to be the ratio of the input price. Okay, so that's the slope of the isocost. Okay. There are two other useful information that you might use when you have a question. So first, assume that the firm is using no capital. So you set K equals 0. The question is, how many workers is the firm going to hire for that given cost? Okay, so in that case, then the number of workers is going to be total cost divided by the salary. Okay, that's the maximum number of workers you can hire for that level of costs. Okay, and this gives you the intercept on the x-axis here. So that's TC over W. Okay, now you can do the same. You can say, what is the maximum amount of capital I can rent for that level of costs? So you set L equals 0, you don't hire any worker, and then you can check that the maximum level of capital will be total costs divided by V. Okay, and this gives you the y-intercept here, total cost divided by V. Okay, so the isocost line is very similar to a budget constraint. Okay, remember when we talk about a consumer choosing between two goods and facing a budget constraint, we could determine the maximum amount of each good it could buy given its constraint, and that would give the intercepts here. So that's very similar. All right, do you have a question on this? That's something you should know. That's going to be very useful. All right. Okay, so let's move to question 4. Assume a firm spends 500 on two inputs, so labor and capital. If the wage rate is 20 per hour and the rental cost of capital is 25 per hour, the slope of the isocost curve will be. Okay, so that's why I said that this is useful. We have just seen that the slope of the isocost is minus W over V. Okay, so slope is minus W over V. Okay, so what is W here? It's 20. What is V? It's 25. So you divide everything by 5 and you end up with 4 over 5. Okay, so you have your answer C here. All right. Okay. If you have question, you can also use the chat, yeah, or you can use the chat to answer my question. Okay. All right. Okay, so question 5. Which point on the graph shows the optimal combination of inputs? Okay, so what do we have on that graph? So first, you can see that we have two isocost lines. The first one is C1 and the second one is C2. Okay, so this line corresponds to different level of costs. And then we have this curve. What is this curve here? Okay, Q1. So this curve is the Isoquant. Okay, so again, the Isoquant describes all the possible combination of labor and capital that gives you a same level of output. Okay, so the purpose of a firm is, given that the firm wants to produce a certain level of output, so for instance, the firm wants to produce Q1 here, the firm wants to minimize the total costs of the output it uses. Okay, so what the firm is going to do is to pick up the combination of labor and capital that will be on the lowest possible isocost line. Okay, so basically you want to be as far as possible in this direction. Okay, so the intersection between, it's not an intersection, it's a tangency between the isoquant and the isocosts is going to give you the optimal combination of capital and labor, the one that minimizes the cost, given that you want to produce an output level Q1. Okay. So what is the optimal combination of input on that graph? Well, point A. So in point A, the production process is capital intensive. You can see it because the level of capital is very high and the level of labor is very low. So what happened in point A? Well, in point A, the firm is producing Q1 at a cost of C2. Okay, so in point A, it's not necessarily the best combination. Why? Because the firm can produce the same amount of output by reaching a lower isocost line. So if you look at point B, in point B here, the firm is still producing Q1, and B also lies on a lower isocost. Okay, so basically isocost C1 here is lower than isocost C2, which means that, let's say this corresponds to a total cost of, I don't know, 2,000, and this is going to correspond to a total cost of 1,000. Okay, so here the firm is able to produce Q1 for a lower cost. All right, so the answer here is point B. Okay, if we look at point D, what happened in point D? Well, again, the firm is producing Q1 with a lot of labor and not much capital. So we said that the process is labor intensive. But again, to produce Q1, it can just reach a lower isocost curve C1. Okay, is it clear? Yeah, so the answer here is point B, okay? So point B, yeah, that's the optimum, all right? Okay. So no question on this? Yeah, so this is not a utility. That's very similar to a utility, to an ISO utility, okay? That's an isoquant. Okay, so again, an isoquant is a combination of labor and capital that gives you the same level of output. So optimums are going to be different for each isoquant. Okay, so for instance, if you want to increase the scale of production and you want to produce, let's say, a level of production Q2, okay, then you're going to reach a higher isoquant, but to reach that higher isoquant, you will have to hire more workers and to rent more machines. And so you will end up on a higher isocost line, okay? And here your optimum will be, again, the tangency between the isoquant and the isocosts. Okay, so that's going to be another optimum. Okay. Exactly. So here, what we call the optimum will be the point where you reach the least costs in terms of inputs, and you reach the highest isoquant given the constraint of the isocosts. Okay, so you want the the isoquant to be the farther northeast, and the isocost to be the farther southwest. Okay. All right. Okay, let's move to question 6. The firm employs 100 workers at a wage rate of 10 and 50 units of capital at a rate of 20. The marginal product of labor is 3 and the marginal product of capital is 5. Okay, so the firm is producing its current output level at the minimum costs. So what does it mean? This option means that we are actually in optimum here. Okay. Option B says the firm could reduce the cost of producing its current output level by employing more capital and less labor. Option C says the opposite, employing more labor and less capital. And option D could increase its output at no extra cost by employing more capital and less labor. Option E, both B and D. All right. So for now, we have just introduced the optimum graphically. Okay, I've just told you we are looking for this point of tangency between the isocost line and the isoquant. But now we want to be more formal with that. So in optimum, we want the slope of the isoquant to be equal to the slope of the isocost line. Okay, so let's write that down. So what is the slope of the isocost line? Okay, so we said that the slope of the isocost line is the input price ratio. Okay, so slope of isocost line. So in optimum, this is going to be equal to the slope of the isoquant, which is the rate of technological substitution. Okay, remember from last chapter, when you have a isoquant like this, the slope in any point of the isoquant defines the rate of technical substitution. Okay, in other words, how many units of labor do you need to compensate the loss of 1 unit of capital? Okay. So the rate of technological substitution, what is it? Well, we know, so let me just write slope of isoquant. Okay, so the rate of technical substitution, we know that this is a ratio of the marginal product of labor over the marginal product of capital. Okay, so in other words, if we are in optimum, then this equality must hold. Okay, so now let's just plug the number and see whether this equality holds. So wage is 10. Rate of capital is 20. Okay, and we want to know if this is equal to the ratio of the marginal productivities. So the marginal product of labor is 3 and the marginal product of capital is 5. All right, so this is equal to 0.5. You can check with the calculator, and this is 0.6. Okay, so basically the ratio of the input price here is lower than the rate of technical substitution. Okay, so the first thing we can conclude here is we are not in optimum. Okay, now the question is, where are we? So what does this mean? So let me draw a graph again. There are 2 ways to solve this question. I'm going to start with the graphical approach. Okay, So labor, capital. This is the Isoquants, and this is the Isoquant. Okay. So here, from this expression here, we can see that the slope of the Isocost is lower than the rate of technical substitution. Okay, so where on this Isoquant is the rate of technical substitution higher than the slope of the Isocost line. Okay, so you can just draw the tangency here to see it. So here, if you draw the tangency of the Isoquant, you can see that the slope of this line is higher than the slope of the Isocost. Okay, can you see this? Okay, so this means that we are actually on an Isocost line which is higher than the optimal one. Okay, so we are here. All right, so again, in that point, the price ratio W over V is equal to the rate of technical substitution. Now we have the price ratio who is lower than the rate of technical substitution. So here the price ratio is the slope of that line. And you can see that this line is flatter than the red line here. Okay. So what can we say knowing that we are here? So we are here and we are employing that amount of capital and that amount of labor. In optimum, we would be choosing that amount of labor. I put a star here on labor to say that this is the optimum, and that amount of capital. Okay. So here, clearly, the firm could reduce the cost of producing its current output level by doing what? If we compare that point with the optimum here, well, the firm could achieve the same production level Q by increasing the quantity of labor and by decreasing the amount of capital. Okay. Do you have a question on this?
So it's just C?
So, yeah, you want to know what is the answer. Employing more labor and less capital. Okay. So could you say that if the slope is higher than Isoquant slope, Y needs to be reduced? Yes. And if the slope is lower than Isoquant, X needs to be reduced. Yes. That's a more general statement. So basically, you can split your graph into two parts. So on the left-hand side here, it will always be the case that the price ratio W over V is lower than the rate of technical substitution. Okay, you can check by comparing the slope of the two. Okay, when you are on the right side here of the optimum, then you will have the opposite relationship. So you will have the price ratio, input price ratio, that's going to be higher than the rate of technical substitution. Okay, so to check that, you can just draw the tangency to a point. Oh, let's do it here. Okay, so here I'm drawing the tangency to the isoquant. Okay, and I can see that, well, the slope of this tangent is super flat. Okay, and it's definitely flatter than the price ratio, than the slope of the isocost. Okay, so here it's gonna be true that we'll have this relationship here. All right. Okay. So this is the graphic solution for that question. I would like to give you an alternative way to solve this. All right. And to think about this more intuitively. So we're gonna start with this relationship that we know is true in optimum. Okay, so we are going to rewrite this relationship that way. So I have the marginal product of labor divided by the wage must be equal to the marginal product of capital divided by the price of capital. Okay. So you can calculate this value. Here, marginal product of labor is 3 and the wage is 10. And marginal product of capital is 5 and the rental rate of capital is 20. Okay, so you have 0.3 lower than 0.5. So what does it mean here? It means that spending an additional $1 in labor is going to increase your output by 0.3. Okay, so if you invest, so investing $1 more in labor generate an increase of outputs of 0.3. Okay, so that's what MPL over W means. And what about this? This means that if you put $1 more in capital, then you are going to increase your production by 0.5. Oh, sorry, 0.25. Okay, just that way. Okay. So if you invest $1 more in capital, then your production is going to increase by 0.25. So just by looking at this, it means that you will be better off switching $1 from capital to labor. Okay, why? Because if you invest $1 less in capital, so minus $1 in capital, your production decrease by 0.25. But if you invest that same dollar in labor, then your production is going to increase by 0.3. Okay, so by just shifting this dollar from capital to labor, you are able to increase your production. So you have a net gain of 0.05. You are able to increase your production by 0.05 while keeping the same level of costs. Okay. Yes, exactly. There was a mistake here. I put 0.5 and it was 0.25. You're right. Okay. So,
Sorry, can you repeat the alternative method?
all right. So the alternative method is to start with this relationship. Okay, so the marginal productivity of labor divided by the wage. So this indicates your increase of the increase in output when you invest $1 additional dollar. Okay, why? Because you have the marginal productivity of labor and you normalize it by the wage. Okay, so for each additional worker you hire, then you will be able to increase your production by this amount. Okay, so here, if you calculate this ratio, you end up with 0.3, which means that if you invest $1 additional dollar in labor, then it's going to increase your production by 0.3. Okay. You can do the same reasoning with capital here. Okay. So here, this gives you your increase in production when you buy another machine, an additional machine. Okay. So if you invest $1 additional dollar in capital here, then your output increased by 0.25. So looking at those two numbers, you want to invest where you will get the more increase in output. And it's definitely by increasing labor. Okay. So because this ratio here is higher than that one, you have an interest in shifting $1 from capital to labor. Okay, so you want to invest less in capital and invest more in labor. Okay, that way you're gonna reach the optimum. Question? Okay, just to finish on this, what happens when you invest an additional dollar in labor? Remember the relationship between the quantity of labor and the marginal product of labor. Okay, it is a decreasing relationship. We have seen that in the last chapter. Okay, so here you have this inequality here. You want to reach the optimum, so you want to reach the equality. So there are two ways in which you can reach this equality. Either you make the marginal productivity of labor smaller, or you make the marginal productivity of capital higher. Okay, so either you want to decrease this number or you want to increase that one. Okay, assume that you want to decrease this number. You decrease this number by decreasing the marginal productivity of labor. So let's say you are here, you hire a worker. How you decrease the marginal productivity of labor? Well, going that way, by hiring an additional worker. Okay. All right. All right, let's move to question 7. A fast food restaurant currently pays $5 per hour for servers and $50 per hour to rent ovens. Determine whether the restaurant is minimizing its cost of production when the ratio of marginal product is 12. If not, what adjustments are called for to improve the efficiency of in-resource use? Okay, so that's about the same question. It's just that the data are a little bit different. So here again, you want to know whether you are in optimum. In optimum, we are looking, as always, for this relationship. So the ratio of input price must be equal to the rate of technical substitution. Okay, that's in optimum. So the rate of technical substitution, we know that this is MPL over MPK. Okay, so we are just going to replace the number and see whether the equality holds. If not, we'll discuss whether we should increase labor or capital. Okay, so the wage is 5. W is 5, and the rental rate of ovens is 50. Okay. And we are told that this ratio is 12. So here we have MPK over MPL, which is the inverse rate of technical substitution. Okay, so here you're not going to put 12, but 1 over 12. All right. Okay, so we don't know if this is equal. So 1 over 10 is definitely bigger than 1 over 12. Okay. So here we are not in optimal, for sure. How can we reach the optimal? Well, we clearly want this number to increase, all right, because this number is too small. So to increase this number, we're going to play with that. So to increase this number, either you increase the marginal productivity of labor or you decrease the marginal productivity of capital. Okay. Again, you can draw your marginal productivity of labor and capital graph. I'm going to do labor here again. I want to increase the marginal productivity of labor, so I want to go that way, which means that to reach my optimum, I'm going to hire less worker and more capital. Okay, that's going to decrease my marginal productivity of labor. This is going to increase the marginal productivity of labor. So this is going to increase this ratio here, and I'm going to reach the optimum. Okay, so the answer to this question is I want to increase the rate of technical substitution by hiring less worker and using more capital. Okay. All right. So these two questions here on whether we are in optimum are really the core material of the chapter. Okay. You should really be confident answering this kind of question, either by using a graph and thinking by drawing a graph, or using this relationship here. Okay, that's really important. Question? No. Okay. All right. So this is a conceptual question. A firm's expansion path is a firm production function, a curve that makes the marginal product of the last unit of each input equal for each input, a curve that shows a least combination of input needed to produce each level of output, none of the above. Okay. So what is a firm expansion path? Okay, so we have seen that the point of tangency between an isoquant and an Icicles line gives a least cost combination of capital and labor. Okay. Now, the idea of the firm expansion path is to give the series of this combination, of this optimal combination for different level of output. Okay, so here I have drawn my optimum from one level of output, and now I'm going to do it for another level of output. Okay, let's say Q2, and you can continue like this. Okay, sorry. All right. Okay, so the line that passes through this optimum combination of capital and labor for different level of output is the firm expansion path. Expansion path. Okay. So a firm expansion path is defined, as you can see, it has to be defined for a given level of wage and capital rate for a given W and V. Okay, why? Because, well, the slope of my isocost line is going to be the same. Okay, so for a given level of wage and a capital rate, you can determine what are the optimal combination of capital and labor for different scale of output. And the line that passes through this optimal combination is the expansion path. Question on this? Right, C. Okay. Yeah. All right. Suppose the production function for coffee is, so we have a production function here, where B is beans in pounds and W water in gallons. Suppose the price of water is 0.1 and the price of beans is 10. So here, basically we want to get the equation of the expansion path, okay? All right, so first, let's look at this production function here. Okay, it has a specific shape. What does it remind you? What can you say about beans and water? So literally, this production function says, I can produce let's say one coffee by using 1 pound of beans and 1 gallon of water. Okay. So basically here, beans and water are complement in the production process. Okay. For each pound of beans, I need 1 gallon of water. Okay. If I have 2 gallons of water and 1 pound of beans, then I will still produce 1 coffee. It's not going to increase my production in coffee. Yeah, they are perfect complement. Exactly. Exactly. So someone has the answer already. So I'm going to show you how we get the answer. So when you have perfect complement like this, so I'm going to put beans on the x-axis and water on the y-axis. So here we have a one-to-one relationship. So if I use 1 pound of beans and 1 gallon of water, then I'm going to produce one, I don't know what, of coffee. Okay. Same, if I increase to 2 pounds of beans, then I'm going to use 2 gallons of water and I'm going to produce a quantity of 2. Okay. So what is the expansion path here? Again, the expansion path is a series of optimum when you change the level of production for given price, for given input prices. Okay. So here, your expansion path is going to pass through the corner of the isoquant. Okay, so that's going to be the expansion path. Okay, so you can change the price of water, the price of beans, or whatever. It's not going to change that. I'm going to need 1 pound of beans and 1 gallon of water to produce 1 coffee. Okay, so what is the equation of this expansion path? Well, now it's quite obvious that the equation is that one. Okay. My optimal relationship between beans and water is 1-to-1. Do you have question on this? No? Okay. So here you can notice because you can't substitute one input for the other, then the price of both input are going to be irrelevant for the expansion path. But in general, it's not going to be the case. In general, the price of inputs are going to intervene in the equation of the expansion path. I'm going to show that to you in the next question. Okay, question 10. So here, our production function is what we call a Cobb-Douglas production function. Okay, so here you will be able to make trade-off between the amount of capital and labor to achieve the same production labor. Okay. So here the question is, the expansion path depends on, okay, when, wage, rental rates, both or neither, and I have added, give the equation of the expansion path. Okay, so what we're gonna do, we're gonna start with that. Okay, and once we get the equation of the expansion path, then we're gonna see whether it depends on something, on wage or rental rate or anything else. Okay, all right. Okay, so what is the property that is true in this point, in point A and in point B? We want something that is going to be true and that we are going to use to derive the equation of the expansion. So in both point A and point B, for given W and V, we have W over V equals RTS. Okay, so this is going to be true both in A and B. So let's just replace RTS by marginal productivity of labor over marginal productivity of capital. Okay. So we have the production function. So now we are able to specify what are the marginal productivity of labor and the marginal productivity of capital. So the marginal productivity of labor, we're going to use a little bit of calculus here. The marginal productivity of labor is the derivative, the partial derivative of the production function with respect to labor. Okay. So I'm going to take capital as a constant, so k to the power 1/2, and I'm going to take the derivative with respect to L. So that's going to be 1/2 L minus 1/2. Okay, so that's the expression of the marginal productivity of labor. We do the same for capital. So the marginal productivity of capital is the partial derivative of the production function with respect to capital. And in that case, I'm going to consider labor as a constant. And I take the derivative of k to the power 1/2, which is this. Okay. So now that we have both marginal productivities, we can calculate the RTS. Okay, so RTS is MPL over MPK. Okay, so MPL is 1/2 K to the power 1/2, L minus 1/2 over 1/2. So now I plug in MPK. So K minus 1/2, L 1/2. Okay. So the RTS is the 1/2 cancel out, and this is going to be K over L. Okay. So the rate of technological substitution here says that if I increase capital by 1 unit, then I will decrease labor by 1 unit, okay, in optimum. All right, but remember, the relationship that we care about is this one, okay? So let's write W over V. Now we have the expression of RTS, which is K over L, okay? And that's going to define our expansion path, okay? To get the equation of the expansion path, again, I want to express K as a function of whatever other variable I have, okay? So the equation of the expansion path will be K is equal to W over V times L, okay? All right. So I have the equation of the expansion path. So now that I have this equation, I can answer my question. Okay, what can we see? Yeah, exactly. You can see that here the expansion path depends on both the wage rate and the rental rate. Okay, so when inputs are substitutes in the production process, in general, it's always going to be true that the expansion path is going to depend on the price of both inputs. Okay? Remember, in the previous question, our inputs were perfect complement, and price didn't play any role in the expansion path, in determining the expansion path. Okay? All right. Do you have question on this? All right. Okay, so now the question is, why is the expansion path important? All right. So it is important because we are going to use the expansion path to actually build the total cost function. So let's look at this question. So I gave you the answer, but I'm going to show you why. So here, I'm going to underline the expansion path. So what can we build from this information? All right. Okay. So let's look first at point B here. What information do we have? We know that we are producing 200 units, okay? And we know that in optimum, we are able to produce these 200 units by spending $2,000, okay? So this gives us the relationship between, I'm going to put Q on the x-axis here. So when I want to produce 200 units, then it's going to cost me $2,000. So here on the y-axis, I'm going to get the total costs. Okay, here I have point B. Now let's look at point C. What can I read here? Well, here I read that if I want to produce 300 units, then it's going to cost me 3,000. Okay. So I'm able to draw point C here. That's going to be 3,000. Okay. So in other words, from the firm expansion path, I will be able to derive the relationship between the quantity produced and the total cost of producing that quantity. Okay. All right, so here the answer is answer C, obviously. Yeah, so here, exactly. No, someone said long run average total cost. So it's true that from this relationship, from this graph, once you have drawn that graph, you are able to build the average total cost graph, okay? But really, the expansion path gives you the information between the quantity produced and the total cost of producing that quantity. So that's the basic information you can read from the graph. And someone said long run. Yeah, why are we talking about long run here? Remember, the difference between the short and the long run is that in the long run, all the input factors are variable. Okay, so in the long run, you can change the number of workers you want to hire, and you can also change the amount of capital, okay, the amount of warehouse that you need, or the amount of land that you need. Okay, so in the long run, both labor and capital are variable. And here, when you look at the expansion path, you are kind of making this, you are making this assumption, right? You are saying that if you want to increase the quantity from 200 to 300, then you're going to increase the amount of labor, but you also authorize yourself to increase the amount of capital. So when you build the expansion path, you are actually building the long run expansion path, when you can actually change the level of both input factors, okay? Which means that the total cost curve that you derive from that is going to be the long run total cost curve. Okay? All right. Okay. So let's move to the next question. So this graph enable us to make the transition between the production function and the costs, okay? And now we are going to work with costs only. Okay. So we have a production function like this. And in the short run, you're gonna fix the amount of capital at 100. So the wage is 10 and the rental rate on capital is 20. What is a fixed cost? Okay. So remember our expression for total costs. So total cost can be either a function of the quantity produced, okay? But we have also introduced another expression of total cost, which is a function of how many workers you hire, what is the amount of capital, what are the wage and rental rate of capital, okay? So here we're gonna use, because we have no information on Q, we're gonna use that expression. So the total cost here is WL plus VK, okay? We said that we are in the short run and that in the short run, K is 100. So that's, so in the short run, then WL is gonna be your variable cost and VK is going to be your fixed cost, okay? And here we are told that K equals 100. So it's going to be 100 times the rental rate of capital, 20, okay? And that 2000. Okay. So not 20, 2000. All right, 20 times 100. All right. All right. Let's move to the next question. So we have the same production function. And again, we are in the short run. Capital is fixed at 100. And we have the same wage and rental rate. Okay. So here's the question is, what is the short run marginal cost? So here again, you can write down, so the total cost, I'm just looking for my notes. Okay, so this disappeared. All right. Okay. So in the previous question, we have write the total cost like this, WL plus VK. Okay. So first, let's just replace W, V, and K with their value. So W is 10, L plus V is 20, so K is 100. Okay. So we have 10L plus 2000. Okay. So the total cost in the short run total cost is this one. Okay. What is the marginal cost? Marginal cost is the change in cost, the change in total cost when you produce an additional unit of output. So here, if you want to calculate the marginal cost, you're looking for the relationship between total cost and Q. Okay, you want to see how total cost change when Q change. Okay, and for now, when we look at our relationship, we have total cost as a function of L. Okay, so we'll need to get rid of that L and to try to input the Q instead. So how can we input Q here? Yeah, someone is very fast. Well, we have the production function, right? Okay, so the production function says Q equals K to the power 1/2, but in the short run, we can simply put 100 to the power 1/2, L to the power 1/3. Okay, so you can rearrange that, and you are going to express L as a function of Q. So that's Q over 10. All right. So you put it to the power 3 to get L, and you get Q to the power 3 over 10 to the power 3. Okay. So now that you have the expression of L as a function of Q, you can plug it back in your short-term total costs. Okay. All right. So the short-run total cost is 10 times Q to the power 3 over 10 to the power 3 plus 2000. Okay. So you can simplify this. That's Q to the power 3 over 100 plus 2000. Okay. So now we have our short run total costs. but we are looking for the marginal cost, right? So how do we get the marginal cost? Well, we're going to use calculus. Marginal cost is going to be the derivative of the short run total cost with respect to Q. Okay, so what is it? That's 3Q to the power 2 over 100. And that's it. Okay, so the expression of the short run marginal cost is that one. Okay. All right. So let me check. I just want to check whether I'm doing one more question. No, let's stop here. So we have done 13 questions out of, I believe I put 18. 18, okay. 19, okay. So what I would like you to do is to continue to try to solve this on Piazza. You have basically until next Tuesday to do it, okay? If you need me to, for clarification question, don't hesitate to ask questions on Piazza, or I'm also available for office hours. Don't forget that, but it's gonna be by appointment only, so just send me an email and let me know when you want to meet. Do you have question on that problem set?
I was just wondering if you're going to be uploading the problem set with the work you did on it, like all the equations and stuff.
I believe I can do it. Yep. Yeah, I'm not sure that the cleaner I could do, but yeah, for now I can upload it. And next Tuesday I'm gonna upload the full solution. Anyway, but you can use it. Yeah, okay. So I'm gonna upload that, and I believe that this class was recorded. So I'm gonna check if it works, and I'm gonna send you the link as well. Okay? Other question? Nope. All right, so I guess I see you next, not tomorrow, Wednesday, but next Wednesday. And next Wednesday, we're gonna cover profit maximization. That I believe that's not going to be new. Just a little bit more math than what you did in Eco 1001. Okay? Yeah, so thank you all, stay safe, and that's it. Bye-bye.